The first component is the aperture of the lens. It is a term that refers to how wide the opening of the lenses that lets these light rays hit the image sensor in camera. Here's a quick example. On the left, you can see an underexposed image that is too dark because of using a very small lens opening. And then on the right, you'll see a picture that is very much overexposed or much too bright when a large lens opening has been used. And the one in the middle shows a correctly exposed photo, which uses a medium-sized lens opening. Sometimes, the lens aperture is referred to as f-stops, and these f numbers refer to the size of the lens opening. However, one thing that you need to remember is that the larger the number, the smaller the lens opening. If we go back to our example, the very small lens opening on the left has an f-stop of approximately f32. The one on the right, which is wide open or almost wide open, has an f-stop of 2.8. So the smaller the number, the larger the lens opening. And conversely, the larger the number, the smaller the lens opening. This may seem a little counterintuitive to some, but it's one of the things that you will start to remember once you explore this topic in more detail. Shutter speed is another variable with digital cameras. A shutter is a mechanical device that opens and closes when you press the button on a camera to take a photograph. This shutter opens to let light into the camera through the lens. The focused light rays will then hit the image sensor to expose the image. And this shutter can stay open for just a fraction of a second, or it can stay open for many seconds or anywhere in between. In this example, pinwheel on the left looks frozen without any blurriness because a very fast shutter speed has been used, something like a 500th of a second. And this only momentarily let the shutter open and let light come in to expose that image. In the second image, a slower shutter speed was used. The shutter stayed open for a longer amount of time and allowed the pinwheel to turn past its initial frame, leaving some blurriness in the photograph. The blurriness is more dramatic in the image on the right, where the shutter remained open much longer for several seconds. So the faster the shutter, the clearer the image, and the slower the shutter, the blurrier the image. However, please keep in mind that slow shutter could be used for creative photography purposes. Here are some examples of images taken with slow shutter speeds. Here's one with a shutter speed of 4 seconds, creating an effect of light painting. Here's another one taken with a shutter speed of 1 second. When taking an image using a slow shutter speed setting, I suggest that you use a tripod to avoid motion blur from hand holding the camera. The final fundamental element in photography is ISO. The ISO setting on a digital camera controls the sensitivity of the camera sensor to light. The lower the ISO number, the less sensitive the camera is to light, and the less grain will be visible in the image. The higher the ISO setting, the more sensitive your camera is to light, the more the image will appear grainy. Since the ISO setting controls the camera sensitivity to light, it also affects shutter speed when you use the camera's automatic or semi-automatic exposure modes. A higher ISO, such as 800 or higher, is good for taking photos outside when the weather is cloudy, or inside in an area with low light. When the ISO is set higher, it allows you to take a well-exposed image when using a fast enough shutter speed so that there is no blur. On the other hand, a lower ISO of 100 or 200 is good for taking images outside in bright daylight or in a well-lit room indoors. However, when the sensor becomes less sensitive to light, the tripod may help, since a slow shutter speed will be used to get a well-exposed image. Here is an example of how high and low ISO affects shutter speed. The image on the left was taken handheld without a tripod with the ISO set to 100. This resulted in a shutter speed of 1 second in order to get a proper exposure. The photo is blurred due to the handheld motion. The image on the right was also taken handheld, but the ISO was changed to 1600. This resulted in the shutter speed of 1/30th of a second, resulting in an image that was not nearly as blurred. You may be wondering if high ISO settings are useful when taking images in low light conditions. Why not always use high ISO settings? The answer is because the higher the ISO, the more digital noise or graininess will be visible on your digital image. In the image on the left, the ISO was set to 400, while the image on the right was shot with an ISO setting of 12,800. They may look pretty similar here. However, when you crop and enlarge the image, you can see much more graininess in the high ISO photo on the right. Well-exposed photos result from the combination of several variables: how much light there is, what lens opening or aperture your camera is set at, what ISO setting is being used, and how long the shutter remains open. The best way to learn how each of these variables affect your photos is to take as many pictures as possible at different settings, and then carefully review the images and the settings to see how these different settings affect each photo you take.